Welcome back, everyone, to Delta Why. This week, guess who's back?
Grayson, I am back from a 4-week vacation.
Yeah, so we're both back together now, and so let's get this week at Delta Why rolling. So this week we'll be talking about a mobile instant diagnosis of viruses.
And 3D printing 100 times faster with light. Although this week we're only going to be doing 2 articles just because of length of time, so it's a little bit shorter for everyone to process, and we're able to kind of cover this a little bit more in depth.
We just want to try this out to see what you guys thought. We thought it might get a little more engagement and a little more, just a little more in depth. So as always, I'm Josh.
This is Grayson.
And welcome to Delta Y. Alright everyone, so our first article for this week is on a mobile instant diagnosis of viruses. And this comes from a team at CRAD who has recently used nanopore technology to sequence the entire genomes of 2 yam RNA viruses. And when I say yam there, I mean the food yam.
Like a potato, basically.
Yeah, pretty much a potato. It's a knockoff potato.
Knockoff potato, golden
But this
potato.
is a new high throughput miniature and portable sequencing technique, and it's been in development for a few years. For both human and animal health purposes. So it uses a mobile laboratory to diagnose viruses, such as Ebola or Zika, almost instantly. And yeah, so these diagnoses are really quick and early, and they don't need to be transported. So this really eliminates the contamination of samples.
Okay.
And it's really cool because they've been able to sequence the entire genome of two single strand RNA viruses.
Okay, and then it reads on to say that it can also be used to diagnose viruses such as Ebola and Zika as well, both of which have vast epidemiological, implications in terms of tracking where patient 0 came from in those cases of the viruses, because their incubation time's fairly limited, right?
Exactly. And so this is really cool because, before, up until about recently, we've been really having to send out samples of blood to, far off to, Europe or America to get samples done for, I shouldn't say samples done. I should say send them there to get samples tested these viruses.
Make sure the viruses are or are not in that sample population.
Exactly. But in this case, we could contain the virus still, and we could just send it to a portable lab on the continent, in the country, in the town even.
Yeah.
These could be moved around pretty easy. I'm understanding that they're relatively small. And so, by doing this, we could eliminate any cross-contamination. You don't have people moving around the globe that could harbor these viruses.
Well, that plus is also the fact that you don't have to be moving around. It wouldn't be, I think there's additionally the contamination aspect, but the rapidity of the, sampling or the completion of the analysis of the sample is actually more intriguing to me, because you're no longer having to spend 5, 6, 7 days analyzing a sample in a far-off country, whereas it's on the it's pretty much set the time frame forward in terms of how fast we can test samples and then go forward with either quarantines or go forward with treatments or vaccinations for certain populations of rather deadly viruses like Zika or Ebola.
And the other cool thing is that, by shortening these times, you can get the virus at an earlier stage.
Yeah.
And when it's more prone to,
where it's
being destroyed.
It's in its incubation period, and it isn't actually ready to spread yet because it hasn't become viral enough, or it isn't.
It's not strong enough.
It's not strong enough. It doesn't have a large enough viral load inside the human body to actually populate out either to the lungs or the skin for I forget what there's a term for contact, making contact with skin. How some
I used to know what it was.
Fomites. It's like when you can contact skin or through the lungs through coughing. If you can get it before it reaches that viral load within the incubation time, you can pretty much you can nip it in the bud and stop the virus from spreading into a pandemic even.
Mm-hmm. And since both Ebola and Zika have been, a widespread global thing, they've attracted headlines around the world. If we were able to stop them much faster, almost immediately when they started, we would have so many less deaths. The world would honestly be a better place if we could do this. So it's really interesting to see, they've been working on this for a few years. Obviously, they have a lot of time left to work on it, to perfect it, to make it better. Mm-hmm. But, I see this heading in a way where, they've only really done this using plants.
Yeah.
And I see this, maybe we have another year or two until this becomes fully, ready for human use.
Well, like blood samples and whatnot.
Exactly.
Because we could actually use that to even further nip in the bud seasonal viruses like the flu.
And that is mentioned in here, they could also use this for seasonal viruses, such as the flu, such as, anything like that. Which is really cool, too, because, like, you could, in certain regions of even in the U.S., we have very different strands of the flu. So if you're able to set these up in, say each state, you could figure out the flu strand in that state, and you could quicker, and, before the flu mutates to resist the vaccine you've created, you're able to, get a vaccine out that's much more effective, that, works at a much earlier stage, so you're hitting a less powerful flu with the exact genome you predicted.
Yeah.
Like, it's not a mutation.
Yeah, and I think going on from mutations, I think the next, like, the thing that's jumping into my mind is how this is going to play out in terms of antibody-resistant bacteria, how we can sequence that. It doesn't really say anything about bacteria in the article, but I wonder if that can be an expanded function as they begin to work on this more, the CIRAD people.
It could be. And, it's something obviously we'll have to wait and see, what they do, because that's not our field. That's not something we really have specialization in.
No, but I've been interested in this sort of stuff for a while now.
Yeah, I took a couple of biology classes in high school. But, I mean, it's interesting that, like, they're able to do this so fast. They're saying that, instead of having them, like, the way that they're explaining it is just, like, they're going from taking days in a lab to immediate effect, like, immediate results.
Immediate, like, within minutes, right?
Yeah, it's why I'm imagining when they say immediate, they mean, a couple of minutes. But it's, like, that's so ridiculous to think about how far science is coming recently.
Yeah.
It's, like, immediate, like, I can't think of how beneficial that could be to so many people in the world if you could instantly diagnose things for them.
Yeah.
Like, you mentioned earlier, you were mentioning, like, making a joke about WebMD, it being, like, a mobile WebMD. But
mobile WebMD, when did I say that?
a little earlier, not in the podcast.
Oh, yeah, yeah.
But, like, this is honestly really cool. Like, I understand, like, that is a good thought to have. Like, what if it's not fully accurate? What could happen? But
yeah, because I thought it was like a phone app or something.
Yeah.
It just said mobile, and I immediately think mobile phone. I didn't think of it as
that's true. But I understand, like, where you're coming from. Like, we have to think about that. How accurate can it be? Obviously, it takes time to perfect it, but the way that they've been doing plants biology with it, it's really cool to see that if we can do real time analysis of diseases, like, the change that it could have on the world is unmeasurable, essentially.
Yeah, it's able to help stop pandemics a lot faster. We'll have to definitely check and see where this comes in the near future. Probably wrap this one up a little bit here. So I'm going to start introducing our next little article, which is going to be on 3D printing technique, which has allowed 3D printing processes to go at 100 times faster with light. Basically, this comes to us from University of Michigan. Rather than building up plastic filaments layer by layer, a new approach to 3D printing lifts complex shapes from a vat of liquid at up to 100 times faster than conventional 3D printing processes. This was seen earlier in the past couple of years. I think back in 2015, I remember seeing something about a Carbon 1 3D printer that had relatively the same principle, where it was extracted from a vat of resin. Like, this has existed for a while now, SLA printers.
Yeah, my high school had one.
Yeah, but
we had two, actually. One was the original, like, $50,000 ones.
Oh, geez.
But then we got, like, a desktop one.
Okay.
And it was really cool to watch these because, it was never 100 times faster than the filament. It was always about the same speed or slower.
Yeah.
But the resolution and print quality was unbelievable.
Well, I think here it actually details, where is it saying in here? So it's... Yeah, there's basically a new type of resin that's almost immediately reactive with UV, or I think even just regular light, that allows it to harden at a much faster rate that would allow just the resin in general to, once it hardens quicker, you're able to create more structures faster than anything else, like almost 100 times faster than regular 3D printers. So
this would be so cool. I mean, I'm a little skeptical because I know how fast filament 3D printers are. They're really fast if you set them right. And some of them, like the industrial ones, are super fast.
Yeah.
But having the ability to prototype a part pretty much in minutes, less than minutes even.
Yeah. I
mean, it takes minutes to print off some parts, so you can do it in seconds.
Yeah.
That's so cool to think about. Like you could hit print on your computer off a SolidWorks file,
and then watch it like
watch it
bring
grow,
out of the
and
film.
then grab it and just start looking at it and go, I need to tweak this, and go back and tweak it immediately. And resin printers are notorious for having really good resolution and being really tough. And that's really cool to see that they're having this, they're trying to bring speed into it. But I do have some thoughts, like, with this reduced resolution.
Oh, yeah.
But it'll, obviously, there's no pictures with this, but we'll have to see, it could reduce resolution, but...
No, I don't think it does. Actually, part of it's also letting more oxygen through, because oxygen penetrates into the resin and halts the solidification near the window, leaving a film of fluid that will allow a newly printed surface to be pulled away. So it has something to do with oxygen as well as light. And this has been a bit of a battle for SLA printers since they've come into the consumer market. Like, what is it? The Form 1 is the most commonly used SLA printer, I think.
That sounds right. I think that's what my high school had.
Yeah, something like that. It's a little crazy seeing what these kind of things can do, but if it's roughly 100 times faster, imagine having such a small part that you can practically just grab it right off the print bed after you hit print and have it like 3 seconds to initialize. Yoop, done.
I mean, even having like a minute of set time after you do it wouldn't be that bad. Like, these are really cool because with, conventional resin printers, you do let it sit under UV light for a few hours, let it fully harden the resin.
Yeah.
But I mean, if they're able to do this, where they're using a different resin type, where you don't need to do that, that would put resin way ahead of filament printing.
Yeah, and some resins even have a better, like, in terms of, like, mechanically, they have better strain and stress and tensile strengths in terms of how they're constructed and their mechanical structure from a chemical standpoint.
Exactly, and they're much more flexible. Like, I have some resin prints, and you can honestly, like, bend them. And with a filament printer, obviously, if you bend a filament print in the wrong way, it shears.
Oh, yeah.
Or if it can just shatter.
Well, yeah, PLA is weak as heck.
Exactly. But, like, filament or resin printers are just so bendable. I printed off a molecule of something in high school. I don't remember what I printed. But, like, I could sit there and, like, I could play with it. And it would, it would flex, but it would always return back to its shape. And it wasn't, like, gonna break.
Yeah.
I only broke one resin print ever, and I like had to like snap it.
Oof.
And it was like this. It's incredibly tough. So I could see this being, if they are able to scale this up with the automotive industry, just industry in general.
Well, I don't think automotive industry would. Well, industry in general, yeah. Automotive might not be the best place for it, considering resin, like as you were just describing, it's bendable.
That is true.
It might not be the best.
You can infuse hardeners into resin to make it stronger,
but how would that affect the 3D printing process?
Exactly. I don't know. So that's the thing that they'd have to work
because that would most likely contain or some oxygen, like organic compound that would probably inhibit a lot of the hardening because it isn't UV reactive.
And we should mention that they're replacing oxygen with a second light in this 3D printing technique. So what they're doing is, by halting solidification, they can create a different way the resin flows into their prints much differently.
Okay.
So that's really cool to see. Like, they're using multiple lights to do their solidification, and they're not relying on oxygen to help speed that.
Okay, yeah, that plus with the added benefit of it being from the top, or it's basically being extracted from the bottom.
Yeah, they're printed top. Usually you print them, you flip them and do the bottom, and you pull the bottom up with the print bed.
Yeah.
Sometimes you can print them the right way.
Yeah.
But usually when you have a base, you want to print them upside down, and it pulls them out of the resin.
Well, I'm going to ask from experience here. How often have you had to like print stuff with support structures, stuff that you have to clip off?
Way too many times to think about. It's a nightmare.
In a resin printer? Seriously?
They can handle themselves, but like if you start printing off arms of things, like when I printed that molecule, you have to support it all.
Okay.
Because when you're hanging it, it's going to have a tendency to flex.
Yeah.
As it dries. So you have to actually support the resin, and it actually like prints itself onto the support. The supports, I will say though, they're much cleaner than like PLA or ABS supports.
Well, ABS and PLA have their own little technique of doing like a zigzag, and you can kind of just pull it out like a sheet of paper.
Yeah, you can peel it out, but that usually does leave roughness. In my experience, it leaves roughness.
Yeah, and you can't
on your
really,
print.
Yeah, you
and
can't really polish it.
Exactly, you'd have to sand it. But with a resin printer, you're able to clip it off, and it really like you have a tiny little nub, and the nub, if you just flick it with your fingernail, it'll pop off, and you'll have the same surface all the way around.
Wow. Okay.
It's a really cool technique. And
You'll have to show me that molecule if you have it.
I might have it. I have no idea if I do. I might have given it back to the high school. But, it's definitely interesting to think about, this would revolutionize industry if we're able to print stuff so much faster. I just see engineering in general because you're able to prototype and produce things just so much faster.
I mean, I don't think it'd be beneficial for our field as much, but
Exactly. I mean, you can 3D print circuit boards, but that's a whole nother way to do it, and that's
Yeah.
real complex.
well, then you have to get into conductive resin, which is not probably going to be anywhere close to this kind of technique because
it's a whole nother
it's a whole nother ball game.
Yeah, exactly. But this is something I'm interested in following and definitely seeing where this goes because
same.
this is something that could be really beneficial for all of engineering. Really, like everyone could benefit from this in some way.
Yeah.
I mean, I think with that, we're getting near a time where I think we should wrap up.
All right.
We are shooting for a little bit shorter of an episode. We're thinking that if we can shorten the episode a little bit and do a couple less articles, we're going to be able to engage a little bit better about those articles.
Yeah, because it's not going to be that way. We're not shortening things, and that way it's a little bit more of a story for you guys to follow rather than just these short little tidbits. So I don't know, kind of toying around with the idea. Hopefully this works a little bit better.
And we'll have to see how it goes. Obviously, we'll listen to it and see what our thoughts are on it. But as always, I'm Josh.
I'm Grayson.
And this is Delta Y. And don't forget to follow us on our social media links down below. We'll be linking our articles down below. We hope you enjoyed and stay creative.
And we will see you next time.